Okay, so we're going to try this and see if it works here. We're going to try to live stream. We're going to see if anybody makes it in here. If you are here and you can hear me, send me a message of some sort so I know you are here. If you are here, send me a message, leave a comment, whatever that happens to be, and let me know that you are here. If you are here and you can hear me and you can see me, send me, or you can see a calculator, send me a message, see if that works. Yay, I see people coming into the room. Yay for technology. Can anyone hear me? Like, if you can hear me, send me a message in the chat room, and I'm hoping that I can see it. Who, are you guys sending me messages? Okay, oh, we're getting a little bit closer. There's no chat function. Okay, thank you for those of you sending me reminds. because otherwise I swear, hey, Abigail said yes. So somebody can see the chat feature. And I'm going to be honest, Hayden can see it. There is a chat feature somewhere. I don't know completely where, but several people are saying they can see it. And I'll be honest, I don't know how to switch the camera so it faces me, but like I'm here. I've never done this before, so this is me learning as we go. But I'm hoping in just another minute or two we can get a couple more people here. Maybe the good news is today's lesson is a very short lesson. So I think we'll be okay. Like it's not, I was even worried it was a little short today. Let's see here. And probably once we get everyone on, oh, the number went down. Come back to class. Uh-oh. Is that backwards for you guys? And I ask because it is backwards for me, which would be a problem for you. Wonderful, so you can see it. I don't know why I can't read what's on my own screen, but it's there. Let's see here if Zoom is working yet. I was told that the Zoom app might be working. So imagine your teacher masked with a computer and a book and some paper and a notebook running outside trying to get phone service in order to use the app on my phone. But lo and behold, I don't actually know the room number for the calculus room. So that wasn't going to work. Let's see here. Where are we now? 14 people still? All right. So I'm just going to start and because I don't really want to waste anyone's time more than it already is. And hopefully they get Zoom working soon and maybe we can switch back. And if we finish this, then those of you paying attention can go work on your homework and those not can watch hopefully a different class's video because hopefully this doesn't happen all day. Okay, so last night or over the weekend, you guys should have uploaded like that worksheet with lots of boxes. And hopefully you get that uploaded sooner than later. You will notice in the module for today, there are like 2 parts to your homework. There's a Canvas quiz, and then there's some from WebAssign also. And then you guys are going to have a quiz on Thursday. I'd originally thought Friday, but I went ahead and moved it up to Thursday because I don't think we need that extra day. The quiz review will be Wednesday night's optional homework. That's all you'll have to do Wednesday night, but it is available in the Wednesday module. So please start looking at that so you can ask questions sooner than later. So lesson 1.4, continuity. So we are continuing the continuity stuff that we did last week, but we're doing it in a slightly different way. So a couple of examples here. Determine if where there's a discontinuity. Oh, okay. Did it unfreeze now? It might be that when I click off of the window, it freezes and then I have to come back to it. I'm learning. Is it moving again? Okay. So determine if where there's a continuity and its type. So let's see here. You're going to have things like this. A function, and then you're going to have essentially so let's see here. Ashton, I'm taking a guess that it's you then, because it is working for Arash. And if it's working for somebody, then it means it's not me. It might be YouTube of some sort. What you're going to be doing tonight, you're going to need to know some of the graphs and what they look like. So if you don't know what 1 over x looks like, you can always graph that on your calculator. It looks like this roughly. So the question is what type of discontinuity and where? And if you just look at the graph, you can see right here, we have an infinite discontinuity at x equals 0. Infinite because there's an asymptote there. So that's one option. Let's see here. Maybe that's part A. Part B. X squared minus 1 over x minus 1. And if you guys use the knowledge that you learned last year, and even some this year, if you factor the numerator, the terms that cancel will create a whole. And what that means is that we have a removable at x equals 1, because x equals 1 would be where the whole is. So you just need to kind of think about the graphs and think about what's happening. So here's a piecewise. X plus 1 for x is less than or equal to 0. And for x greater than 0, we have a different function. So x plus 1, that's just a line. E to the x, that is exponential growth. And neither of those have any jumps, holes, or asymptotes. A line isn't an issue. E to the x, that's just like, looks like this. Not an issue. No jumps, holes, or asymptotes. The issue could be where you switch from one graph to the other. So what we need to do is we need to make sure that there's no jump at x equals 0. We need to make sure that when we switch from the line to the curve, that they connect, that there's no jump there. So what we do is we see at 0, the first function has a value of 1. At 0, the second function has a value, e to the x, of 1. And because they are the same, there is no jump. And because there's no jump, it's continuous. Okay, that's the first thing. These are like the ones on WebAssign where they're going to be a little more straightforward. Where's the jump? Where's the hole? What type? Things like that. You may have graphs to work with. I believe that most of them have graphs, if not all of them. But we also have one other topic here. And this is a topic a problem usually on the ACP test. And by usually, I mean like, every year I've given it except one, maybe. Like when I say there's a problem that's usually there, you can pretty much guarantee it's going to be there. Plus, if it's probably on the ACP test, then it's probably going to be on a quiz, and it's probably going to be on a test. And it's probably going to be on the final exam. So this would be a really, really good one to know. And this is what your Canvas homework is like. So an example, find a value, k, to make f of x continuous. And then you would be given a function. It's going to be a piecewise function. So 7x plus k and x squared for x less than or equal to 2 and for x greater than 2. So essentially, here's the deal. We have two piecewise graphs. Let me see if I can do this, a visual aid real quick. And just for example, let's say the two graphs look like this, and one half is here and one half is here. What we need to do is we need to figure out which constant to add so that the two graphs meet up. Because without a constant, there might actually be a jump between the two graphs. So we need to add or subtract the k value so that we bring the two graphs together. And the issue where there could be a jump would be this, the spot 2 where they switch. So we must prevent a jump. At x equals 2. And we do that because we want the two functions to be equal. So the steps themselves are actually pretty easy. Step 1, you're going to set the functions equal, or let's say the pieces. Right? Because we want them to be equal when they come together. Then we want to plug in the x value. And 3, solve for k. So for our function, 7x plus k, we're going to set it equal to x squared. And then we want them to be equal at 2, so we're going to plug 2 in for the x. And we use 2 because that's where you switch from one graph to the other. So 7 times 2 plus k equals 2 squared. And solve. 14 plus k equals 4. Move your 14 over, and k equals -10. So in order for those two graphs to match up at 2, we would have to have our k value -10 so that they cross. Now your homework, I believe there are 6 of these on Canvas. You should be good to go. One quick reminder, x equals -b plus or minus the square root of b squared minus 4ac all over 2a is the quadratic formula. That is a good formula to use when you can't factor something. You also could potentially get 2 k values. You're going to know that you have 2 k values because in Canvas, it's going to ask you for both answers. Canvas is set up so you can put your 2 answers in whichever order you want. Just put one answer in one blank and one answer in the other. I think, honestly, that'll be enough to get you through the homework. It was a quick, pretty easy, light day. I don't know what's going to happen when I end stream or if this is going to be available to watch. But hopefully Zoom will start working and I will post a real video of class later for anyone who missed it. I will be here at my computer until class ends officially at 9:15, so feel free to send me an email or a remind if you have any questions. And good luck, and hopefully we get Zoom working soon. All right, talk to you guys later.